Some problems that can be solved with the sine and cosine rule require a little bit more care than others. Consider this question. The triangle ABC has length AB is 8.6, length BC is 5.7, and angle BAC is 35.5 degrees. Find the two possible values of the angle ACB. A picture is going to help here. So this picture summarizes everything in the question. And there doesn't really seem to be anything confusing about this. We have to find that angle ACB, the angle which is at C. Let's approach this in our usual sine way method. We would say that the sine of the angle we are interested in, this time it's angle ACB, divided by the length of the side opposite, which is 8.6, is equal to the sine of the angle 35.5 degrees divided by the length of the side opposite that, which is 5.7. So therefore we have that the sine of angle ACB is 8.6 multiplied by the sine of 35.5 degrees divided by 5.7. That means that the sine of angle ACB is 0.876 to 3 significant figures, and therefore angle ACB, taking the inverse sine of that value, is 61.2 degrees to 3 significant figures. Surely, problem solved. And when we look back at our picture, that seems a perfectly reasonable answer. The problem is that we've been a little bit quick to draw this picture. There's more than one way to draw a triangle that illustrates all the information given in the question. Here's an alternative way of showing the position of C, giving us a smaller triangle, but still with sides of length 8.6, 5.7, and an angle of 35.5 degrees. But you can see that the angle C would be very different. To understand why this is the case, let's go back to our definition of sine. Let's pick a particular value of y between -1 and 1 and draw the line y equals that value. So here's an example for a value of y just over a half. If we draw the point where that line intersects the circle, and then draw the straight line joining that point to the origin, then that point defines an angle between the positive x-axis and this line. And we defined the sine of that angle to be the height of this point above the x-axis. In other words, the sine of that angle is the height of our horizontal line. However, we have to realize that there is another point on the circle which satisfies these conditions. If we join this point by a straight line to the origin, then that point also defines an angle between the positive x-axis and that line. And as both of these points are the same vertical height above the x-axis, both of those angles have the same sine. If we change the height of that line, we can see that there will always be two angles that have the same sine. More than that, it's easy to see the relationship between these two angles. It'll be easiest if we stop this at some point above the x-axis. So the smaller of these two angles could fit in this space between the larger angle and 180 degrees. Therefore, we can find one of these angles by subtracting the other angle from 180 degrees. Going back to our original working, we can conclude that it's also the possibility that angle ACB can be 180 degrees subtract 61.2 degrees, which is 119 degrees to 3 significant figures. This is an example of an ambiguous case. If you are not given a diagram, if you are just given written information, be very careful to think as to whether there's more than one way that you could draw all this information. It's possible to end up in the same situation with a cosine rule question. This was a question that we used in the video which explained the cosine rule, it asked us to find the length of the side x. So going straight for the conclusion we reached there, we did a little bit of algebra, we ended up with a quadratic equation in x, and we deduced that x was either 1.28 or x was 5.65. And we deduced from the diagram we've been given that it must be 5.65 because looking at the length of the side it would be silly to think it was much shorter than the side on the top. But why did we get the other answer? How could that possibly fit in with this information? Well, suppose we hadn't actually been given a picture. Suppose we had just been told that we had a triangle of sides of length 5.5 and 4.8 and an angle of 51 degrees between the side of length 5.5 and the unknown side. Is there another way we could have drawn this information? Again, the answer turns out to be yes. Here's the picture we're given. But if we were to use an alternative position for the side of length 4.8, we would end up with a much thinner triangle. And now the length of the unknown side would be very short indeed. This would correspond to our alternative answer of 1.28. So if the information had been given to us in text rather than in a picture, both would be possible answers. When using the sine or cosine rule, always be aware of the ambiguous case.